in the coffee room still, so basically that's totally fine. We're moving forward to the last part of the conference, the first live official data science DACH, and basically I would like once again I'm very happy to say thank you to all of you who come to the conference. I believe, and I can feel, maybe you can feel from my vibe that I'm totally bold. I have a personal, let's say, passion to say. Because we wanted to this to work as beautiful as it can. We tried to do the OBS last time, and it turns out that it's very hard to do like clicker with OBS. Why? Because the computer registers as the keyboard. So you basically need to do hard coding of the clicker so you can work in some streaming programs. So it's a very, very fun story, but that's why I didn't sleep last night much. I have this kind of thing for technology, like to invest even day before the conference. And basically why I'm saying this because I truly do believe that the company which is going to be represented next is a company that shares the same value, that they are on the brink of the verge of technology. They're trying to build something that can be used by many and for many. And the topic we're going to talk about is something that can easily be called disruptive AI, and that is geospatial machine learning at scale with Amazon SageMaker. Why is this very important thing? Because in the end, we can talk in the first session, if you remember, Michael Model has been talking about how we can use space data and to see how we can like even calculate which building has a problem, maybe we can collapse, so maybe we can save on tons of life. We're talking about geospatial data. I didn't look what's going to be the topic, but they're talking about geospatial data. That's one of the biggest, let's say, the first predecessor for having like autonomous cars, for example, etc. There's tons of good example, and I'm totally sure that this presentation is going to blow your mind. Once again, like I said, a little bit of PR. I would like to say that every participant is going to get also, like, we would like to understand as well. Like I said, lifelong learning is very important for us. That's why we're going to be able to give you like access to the tech tutorials. But also why we would like to do that, because we truly do believe one of the mission of our basic vision of our conference is change world today. That we truly do believe that connected to data that we can really make a change in the world. That we can be the change in the world that we can see. Being said that, we truly do believe that like finding about and being on this kind of tutorial, at least a virtual tutorial, with somebody from Croatia, Slovenia, Italy, as well as Serbia, Bosnia, and that part of Europe, and the part of Europe, there can be a whole mix, and that we can learn from each other very much. So without further ado, I would like to ask Karsten Schroer, who is Solution Architect at Amazon Web Service, to join the stage and deliver his outstanding talk. So one applause for Karsten.
It's okay. Okay. Great. Hello everyone. Welcome to this talk. So my name is Karsten Schroer. As has already been said, I'm a solutions architect with Amazon Web Services. So I think, like many of you, I have an engineering background. Started off as a mechanical engineer, and then did my PhD in applied machine learning. After which I joined AWS. So I used to be super deep in the algorithms and methods, and now I'm much more focused on actual deployment and bringing data science and machine learning to production. Today I'll be talking about geospatial data analytics and machine learning, topic that's very close to my heart. And we'll be looking at how you can actually operationalize that and scale that with Amazon SageMaker. Now, before I start off, can I just maybe ask the audience, who of you is already working with geospatial data, so like satellite imagery, mapping data? Okay, quite a lot. And who of you thinks that working with geospatial data is an overall easy and scalable experience? Yeah, well, not that many. And I would absolutely agree. Speaking from my own experience, it's really tedious. Super large files, manipulating this data requires a lot of very customized, specialized tools. So this is why we basically recently introduced geospatial capabilities into SageMaker, and today I'll talk a little bit about what that exactly is and what that can do for you in your geospatial projects. So let's start off. Stop working, sorry. Let's start off with what geospatial data actually is. So it generally comes in two forms. First one, of course, satellite imagery, aerial imagery from drones and planes. And you can think of this as really large, image files. It's pixelated files. Each pixel has a value, and each pixel will also have multiple channels, right? And a typical, photograph is RGB channels. Satellite imagery, of course, has many more channels. Also covering the infrared and the ultraviolet spectrum, etc. And these files can be super large, right? Just thinking of a single tile of Sentinel data. So Sentinel is ESA's open source sort of satellite constellation. A single tile is like 500 megabytes. So if you're basically surveying over multiple tiles, over multiple days, over multiple years, it's going to be terabytes of data, right? That you need to sort of crunch and prepare. Make it really difficult. The other one, I think, most people will be more familiar with is mapping data. Lines, points, polygons, etc. comes in files like GeoJSONs or shapefiles, etc. So yeah, that's the other stuff. And you can build really cool use cases on top of this data. So one that I really like is Earth observation use cases, like ecosystem monitoring. For example, you can survey large swathes of the Earth, such as forests, even glaciers or water bodies, and track them at high temporal frequency and see very small changes. And figure out lots of interesting stuff about that. We'll be looking into such a use case in just a bit. However, what we see is that actually, getting started with these sort of use cases is really quite difficult, and this is because of a number of challenges that's associated with geospatial data analytics. The first one is really about access, right? So accessing high-quality geospatial data sets is difficult. You typically need to work with multiple providers, mapping providers, satellite imagery providers, etc. And then once you have that, comparing, basically combining the data sets and then preparing them, crunching them, pre-processing them, is less a challenge. First of all, because it's huge data sets mostly, and also because it requires very specialized tooling. And this sort of tooling is not, part of the standard toolkit of your average data scientist. So just getting there, getting up to speed with this, takes a lot of time. And this is basically the fourth challenge, which typically is a skills gap, and just a problem of actually upskilling and getting ready to be able to work with geospatial data. So therefore, we've actually very recently introduced geospatial capabilities into SageMaker. So for those of you who don't know, SageMaker is AWS's machine learning development environment. So it's basically an end-to-end machine learning service that allows you to prepare and also deploy models in a single environment. And this now, also allows you to do geospatial operations in the same environment. And here's how it works. Can you go to the next slide? So basically it covers the whole data science process from end to end. Starts off with accessing with actually predefined data connectors to some of the most important geospatial data sets. For example, Sentinel-2, I already mentioned that. Landsat-2 data as well, and OpenStreetMap data, which you can just basically import with a single line of code. There's also predefined transformation models like resampling, geomosaicing, etc. There's also models that we've pre-implemented, primarily around segmenting, for example, clouds or land cover use. And you can also bring your own, you can deploy it, and then also visualize. And I think the unique bit about this is it's all in a single notebook environment. So it's all in a single Jupyter notebook. Most data scientists will be familiar with this, and we'll have a look in a bit at some code where I can show you how this works end to end. Cool, let's go a little bit deeper into each of these components. Accessing geospatial data. So a lot of the geospatial data that's open source is actually hosted in AWS, so it's hosted in S3 buckets or basically storage servers. So this includes up-to-date satellite data from Landsat, but also Sentinel, and OpenStreetMap data, for example. But if that doesn't do it for you, you can also bring your own. So for some specialized application, you might require some, I don't know, higher revisitation rates or specialized spectral bands that these satellite constellations don't offer. Then you can actually import your own, or if you want to bring your own mapping data, that's possible as well. And you can then also interactively query that data all inside the same notebook. Here's the next step. This is about transforming and enriching, and this is both possible on satellite imagery, so pixelated data, where we have free sampling models, mosaic models, so that's basically for stitching together different satellite imagery, or also bandmap models, where you combine different channels of the satellite imagery. And for mapping data, we have similar very useful tools like UI lookouts, like reverse geocoding. Those are all just simple API calls. Go to the next one. This is the model part where I mentioned there's a lot already pre-implemented. I think two things I want to point out is the cloud removal one, which I think is a super useful model, especially in production. It's essentially a semantic segmentation model that basically identifies pixels that have clouds, then removes those pixels and overlays an image where there aren't clouds, basically generates a new cloud-free observation, which is extremely useful if you're doing machine learning. There's also a pre-implemented land cover segmentation model, so you can get really up-to-date land cover segmentations for any point on Earth, which again allows you to monitor for changes in land segmentation. Moving on. Finally, visualization, which previously required specialized tooling as well. So we've actually built that into the SageMaker notebooks as well, using Foursquare, which of course is a very well established technology for this, and which many data scientists will actually be familiar with. Cool. Maybe I think the key innovation here, it's all in one environment. It's a single SDK. You don't need to learn multiple tools and import those into your environment. It's basically covered end-to-end in a single environment. So next up, I just want to do a quick demo and show you in the code how this actually works. The use case I've chosen is remote monitoring of raw material supply chains for sustainability. Quick call-out, we've actually written a blog on this, so if you're interested, there's the QR code for the blog, which gives you more background also on the code that's underlying. Cool. You move on. So scenario, let's assume we are, a sustainability manager or a supply chain professional, and we want to make sure that the suppliers that we source our raw materials from operate in a responsible manner. So what we do is we actually look at the areas where they operate, where they have their plantations and fields, and we want to look at whether changes in land cover occurred and over what period those changes occurred and how big the areas that were affected are. So that allows us then to actually check if they are operating in a responsible manner. If you go to the next one, so this is essentially what we want to end up with. On the right, you see the raw satellite, actually the left, you see the raw satellite imagery of that area. So it's an area in Brazil that we picked. And on the right, you see this vegetation mask, which is based on normalized difference vegetation index, which is basically computed by with a small operation between the red and near infrared bands. And it's essentially you can think of as a measure of greenness. High values indicate untouched rainforest, low values indicate barren land. So this is what we want to build in SageMaker Geospatial. And yeah, I have a quick demo prepared. It's going to be quick. It's some code, but you don't need to understand it in detail. You click again, and so I've actually pre-recorded this. So this is SageMaker. Looks like a standard Jupyter notebook. It comes with a file system here on the right, and it runs completely on the cloud on its own image, specialized for geospatial operations, and also the instance type. The compute is specialized for that, but it's in Python 3. So what we want to do is monitoring deforestation with SageMaker, and the workflow is the following. We first import the capabilities, we query, start with an observation job, visualize, then export, and finally measure the size of the forested area. So let's start. We import our libraries, specifically the AWS specific tooling, and we set up our SageMaker Geospatial client, pretty standard here. We then basically set our query parameters. We select the coordinates. Don't understand those now. The time and also the maximum cloud cover that we're willing to set here. And then we actually look at the satellite constellation data that's available to us. And as I was saying, we have Landsat and Sentinel-2 available. You can basically query those using what's called an ARN, an Amazon Resource Number. We just summarize the query parameters here. Again, execute that cell. Look at this. And we can now check the number of images that we actually get returned. Again, just calling the SDK here, the API, sorry. And we get 25 satellite images for our query, and can have a quick view. Here's an example, and as you can see, it's all sitting in Amazon S3, so super well integrated here. And we can now start our Earth observation job. I explained before that we want to calculate normalized difference vegetation index, which uses the red and infrared bands. So here we're just double checking which bands we have. These are the bands that we have, and we're using the red and near infrared. So that's all good. And we can now specify our Earth observation job, again, using the input configurations from before, and also setting the operation. Here it's a simple processing operation that we want to run. And that's the computation that we're doing for NDVI. And we can then start off the job with those configurations in terms of inputs. We call out the documentation here. We will just execute that cell, and this Earth observation job is now being started on a dedicated container in AWS. You can actually check the status here, and you can see it's initializing. So typically, such a job would take 20 minutes to run. We can monitor it here, and just for the purpose of this presentation, we'll use an older job that's already completed. And we can now start and visualize that one. So that's the mapping tool, again, all in the same notebook. So we've basically rendered the map. We can now add layers to it. So we'll start with the actual area of observation here, which is just the coordinates that we set before. It's a square somewhere in Brazil. And we can then add the additional satellite imagery that we've retrieved, first the input. So that's going to take a while. As you can see, it's going to load. Obviously, it's a large amount of data, but it's rendering now. So it's pulling in the satellite imagery here for that query that we said. And we can now add the output layer as well, which is the NDVI transformation. So those pixels in the output layer will have values from 1 being completely covered in forest to -1, meaning water or no vegetation at all. You can interact with that map. You can change the order of the layers. For example, pulling up our AOI, you can then also change the representation of each of those layers very interactively. For example, setting this one to red and making it a little bit wider, etc. Just playing around with this a bit. And then you will you could, for example, also pull up the output layer and change the color scheme, etc. So lots of stuff that you can do in this notebook already and this map. Next up, what we want to do, since we're interested in the actual areas that are affected, we want to extract those results, and that's pretty easily done. You just need to specify a location. Here we are specifying an S3 bucket, and we're going to export it to there. And once exported, we can then do the custom analyses like that example, a time lapse that I showed you before. So here, just showing a single year, 2022, looking actually at the progression of NDVI over the different years. You can see it's steadily reducing over the years. Obviously, there's some seasonal variation, which makes sense. And then sticking those two different years together in a time lapse and looking at the change in terms of area. Cool, yeah, that was a quick introduction of what this can do in a single notebook and a single API actually. So I think we can switch to the next one. So I hope that this gave you a good sort of flavor what this tool is capable of. It's now in public preview, which means that anyone can actually start using it, experimenting with it. And I think a really good place to start is our example notebooks. So here is a QR code to the GitHub repository where all these example notebooks sit. Each of them is actually showcasing a different capability. For example, the one here on tracking glaciers is quite cool. It showcases the capability of land cover segmentation and applies it to the case of tracking a glacier in the US mountain range. So you might want to start off with this and maybe even try and see if you can easily adapt it to a mountain, maybe somewhere here in Switzerland. I'm also adding the developer guide here and also the official website, of course, and also, if you go to the last slide, feel free to email me if you have further questions, or actually ask them now. Also very welcome. Thanks very much.
Okay. Thank you, Karsten, for the introduction. Like I was outside the corner. Basically, is there any question for the Karsten right now? Okay, it's all I can see you. I've been awesome. You also? No, you're next.
So, my question is this tool can be used as I was thinking, I will have students, and Geospatial is one of the topics I will probably teach. So these can be used by anyone who is connected in this web service.
Yes, exactly. What you need is an AWS account, and then you can start using it.
And to use and to apply for all kinds of stuff with geoinformatics.
Absolutely, yes.
So is it like similar to PostGIS, geo processing, and everything can be done?
Yes, it's all in one place though, and the full and it integrates with your standard data science environment. Exactly.
Okay, thank you. I will write an email.
Yeah. Okay, some other questions? Okay, once again, Karsten, thank you so much for your time. It was very nice to hear from you. Right now, we are moving forward. Hello everyone, it's me again. I hope that you miss me. They're saying one thing is useful talk Okay, sorry for Serbian. Here, like actually Yugoslavians in the program. So basically, we are moving forward with the program. I hope that we didn't, that you are still staying, that you're still following. There's tons of interesting talks right now happening. And the next one is going to be from Walter people who is head of data science and AI in a company called No Money. I don't know if you understand that this kind of industry has very cool and very interesting topics for today. For example, I personally know that one of the differences when we're talking about gaming and games so much that with the codes are constantly changing, that is the only problem that is not time series like you can do with face. So basically, I think that we can expect a lot from this talk. I expect a lot from Bogdan. I'm not putting pressure, but I am. So basically, Bogdan, the floor is yours. So once we close the Bogdan.